Hello, everyone, and welcome to Godless Family Webcast. I am your host for the day, Amanda Hayes, and with me is my co-host, the usual host of the show, Aubrey Adrianson. Hello, Aubrey.
Hi.
Hi. And also with Aubrey today is her daughter, Aura, who's going to be joining us, and your daughter is 8, correct?
Correct.
Excellent. Okay, and so she really likes evolution from what I've told, and she wants to learn a little bit more about it and ask some questions. For our guest, Scientia, who I'll just let him tell you. Tell us about yourself, Scientia.
Hi, I'm a 6th grade science teacher, and my degree is actually in evolutionary biology. I didn't start out with an education degree. I just stepped into it off of a whim, off of people telling me in college that I explain stuff. My roommates especially explained stuff in a way that was easier for them to understand, even though I wasn't in their classes, and we all were natural history and science majors. So I just kind of stepped into this job, and this is my 9th year as being a science teacher.
Wow, that's excellent. Okay, well, we're glad you could join us. So I guess we can just get started with the questions. We don't, the show is an hour and there's a lot to talk about. So the first thing that I wanted to ask was if you could explain evolution in the simplest of ways without misrepresenting what it is.
Just the simplest explanation is that evolution is a change in allele frequencies in a population over time. And just to get some of these technical terms out of the way, the main one being allele. So basically, a gene has 2 different things that it encodes for. And I'm going to use Mendelian genetics, so Gregor Mendel, to explain kind of his contributions to best understand alleles. So what he did is right around the time that pea plants is what he was using, and right around the time that Darwin was formulating his theory of evolution by natural selection, Gregor Mendel was also doing experiments, this was in the 1850s, with pea plants. And the idea was to find out if traits either mixed or if they were separated from each other. So I asked my students just this last week, if you breed a white rose with a red rose, what color would you expect it to be? And pretty much all of them said pink. But of course, that's not what usually occurs. What occurs is you have either an on or an off kind of position going on. So an allele is basically a gene that codes for a trait, and it's either one trait or another trait. And what Gregor Mendel found out, and I'll just kind of use a couple of the traits that he was looking at, is that the peas would either be green or yellow, or the plants would be tall or they would be short. And there was a little bit of a misunderstanding going on. Basically, the thought was, when he completed his experiments, is that one gene coded for one trait. Of course, most genes don't. So that's what an allele is. An allele is basically the different trait that one gene is coding for. So you can have a green pea or a yellow pea. And what usually happens is that you will find this 3-to-1 ratio. And that's because you have a dominant gene and you have a recessive gene. So even though you have these two alleles on one gene, one being green and one being yellow, maybe the yellow one, even though the pea has both traits, it has the trait for the green and the yellow is dominant over the green, and so the yellow one is the trait that shows up more often. And this gets into Punnett squares and a whole bunch of other science that I'm not going to go into right now unless I'm kind of pressed on it. But again, that a change in the frequency, the number of these traits over time in a population, and I think that's the one point that a lot of people don't understand, that this happens in populations. It is not an individual. So you and I do not contribute to evolution per se. It is the whole population that we're looking at.
Excellent, thank you. So we have a lot of parents who watch the show who have children who need to explain it to them if they don't learn enough at school or if they're not there yet. What would you say are some of the most difficult parts of the theory to understand? yeah, we'll just start with that.
I'd say one of the most difficult parts is that you don't stop being what you once were. And this gets to the question that is often posed by creationists being, if we evolved from monkeys, why are monkeys still around? It's the same thing as asking, if we evolved from the first mammal, why are mammals still around? So this is the idea of clades. And clades is basically the group that you belong to. And if you go through what we commonly go through, the 7 or 8, depending on where you're talking about, the 7 or 8 classification systems of the scientific classification, we are part of each of those, and we never stop being part of those. So the thing that most people understand for scientific classification is kingdom, phylum, class, order, family, genus, species. We are still in the kingdom of Animalia. We never stop being animals. We're not going to change into plants or fungi or bacteria. We're always going to be mammals. So you're always in that higher order of the classification system. And as evolution occurs, there will be splits that occur at lower levels. And so you will go off on one side or the other side of the split, and you become part of that part of the classification system. So, for example, humans are Animalia, Chordata. The subphylum of Chordata is Vertebrata, that we have vertebra. Next comes kingdom, phylum, class. The class is mammals. The order is primates. And then you keep going down step by step by step. You never stop being part of the class that you were put into. And I don't want to say class because it's kind of confusing, because there's kingdom, phylum, class, order. So you never stop being part of that group. You're always part of that group. And along the way, and of course there's all these sub-levels and super-levels parts of it. So at some part of that, and it's right above Mammalia, we were part of a clade that basically puts us in the same clade as something called the lobed-finned fishes. I'm not going to use scientific names because I think it's just a little confusing, but lobed-finned fishes are like the coelacanths. We are in the same clade as coelacanths. They are different from ray-finned fishes in that their fins have the basic structure that our arms, our legs have, which is, and if for a lot of people out there who are keeping up with Neil Shubin's PBS series, Your Inner Fish, they've probably seen this, that you have this pattern that occurs in each one of our arms and legs, where you have one bone, two bones, many bones, and then an array of bones coming off of that. And that's the same thing that these lobe-finned fishes have. And I think that's a key point to understand, is that we never stop being part of that clade that we came from. That at some point there's going to be a split that occurs, and we are in the clade, the parent clade that we originally split from, and then the next step down, we're still part of that clade. So the next clade up from where we're at, basically our species is Homo sapiens. The next clade up from that is Homo, and there are no other genera of Homo left. They're all extinct. But if you go the next clade up from that, if you go into the family of Homodidae, there are many Homodidae out there. We have two different species of chimpanzees. We have the common chimpanzees and the bonobo, and then sometimes people will separate it off into other subspecies. We have the gorillas and we have the orangutans. So basically, we are in the same group as those, which is often called the Great Ape group. So we've never stopped being part of that group, just as we've never stopped being mammals.
Excellent. Okay. So you touched on some of the creationist misconception about evolution. Is there anything else that you can touch on that shows, I guess, that shows that evolution has been proven?
Proven is one of those words I don't like to use, and for anyone who follows me on Twitter, they kind of know that. And I like to use something that I can't even remember who the first person who brought it up, although I'm pretty sure they're British. Proof is relegated to the fields of maths and of making and classifying alcohol. Okay, in science there is no such thing as a proof. The way that science works is there are things that we call facts, and facts are just basically the facts. We know for a fact that when we let go of something, it will fall to the ground. That is a fact. We know for a fact that when we close a circuit and allow electricity to flow through it, that a wire with high resistance will heat up and produce light. That is a fact. But then we need theories to explain those facts. So what is the theory of electromagnetism? How, what is our understanding of what is occurring? The same thing with gravity. People often like to say, oh, there's this law of gravity, which we can shove that off to be Isaac Newton's law of gravity, which is basically that things attract each other. Yeah, that is pretty much the same as a fact. It's an observed occurrence. But then we need to have some way to explain why that occurs. And I think that's the thing most people don't understand about science in general, and especially about evolution. In evolution, we have all these facts, and the one that I like to point out is we have these family trees that we build. Just like we build our genealogy, we are related to our parents, who are sons and daughters of their parents, and so on and so on and so on. When we look at those family trees, there are many ways to build them. I look more like my parents and my siblings than I do to almost everyone else in the world. Of course, every once in a while you'll come across someone who looks a lot like you or looks a lot like your parents. But in the community that we live in, that we grew up in, we look more like our parents. I like to show this photo, and I'm doing this just recently, of my son, who's 3 years old, and myself when I was 3 years old, and you cannot tell us apart. I have been looking through family photo albums recently, and my brother and I, even though we are almost a decade apart, look so much like each other when we're looking at photos of us at a similar age. And that similarity is basically just our physical appearance. But then you build a genealogy off of something else. You build it off of genetics. So you go and you look at the DNA, and if you compared my DNA with my brother's DNA, it would be more similar than anyone else's DNA in the world. That's getting kind of more specific, a real testable observation. Getting to the larger groups, if we look at embryos, the embryos of all mammals look more like each other than they do look like other vertebrates. And they look more similar to one another than, so mammals look more similar to one another, the embryos look more similar to, say, marsupials or monotremes like the platypus than they do to birds or fish or any other group that we're just talking about. And the most interesting thing about that is these are all separate fields. First, you're looking at morphology. You're looking at the physical appearance of an organism. And if you ask any student, going all the way down to kindergarten, going all the way up to college, and you ask them, who do humans look more like if you compare every other organism on the earth? They will say we look more like gorillas or chimpanzees or orangutans than we look like anything else. There's nothing that looks more similar to us. And then you take that piece of evidence and you look at the DNA, and when we look at the DNA, the same thing occurs. The DNA of humans is more similar to those great apes than it is to any other life form. And then you look at the embryos, and the same thing occurs. And then you look at our immune system, and the same thing occurs. You look at all these different fields of evidence, these different facts. These are all facts. They're all observable facts. And the only way to explain them is by this process of evolution by natural selection. Right now, we have no other explanation for that, except for that we are related, and the relationship is found by looking at these family trees that we put together from these different fields, these totally separate fields, and understanding that if evolution is not occurring, then what is the explanation? Is there any other way to explain it? And currently there isn't in science. And I think I'll leave it there. I feel like I'm talking a little bit too much, and I'd like you guys to have a little bit of input as well.
Did you have something you wanted to say? No. I did have a something I wanted to add, because we were talking about misunderstandings of the theory, and you mentioned the why are there still monkeys, and that's a very common misunderstanding. But also the mutation over time, I think, is very misunderstood. A lot of, especially creationists, I hear them say this, um, that evolution, you're going to evolve into another species over 1 or 2 generations, and just kind of understanding how long this process actually does take. If you could
Yeah.
maybe speak to that.
It takes the lifespan of a species on average is about 2 million years. That doesn't mean that you'll only see a new species occurring every 2 million years, because we've had observable instances of, whoa, that was loud, of species occurring within our lifespan, within the lifespan of us personally, and of when people have been actually observing, different speciation events occurring. So how long does it take? It really matters on a lot of different factors. One of the main factors is when you have a biological niche open up. This doesn't happen that often, and usually the way it happens, as far as within human history, is by the occurrence of some dramatic event that allows new environments to occur that have not been there before, such as a volcanic eruption. So volcanic eruptions will wipe out all the life in a certain area, and then you have new organisms that come in, but the area has been changed from the surrounding area. This is the difference between what is called allopatric and sympatric speciation. So basically, when you have this occurrence where a new environment has been formed, then new organisms can start to come in to that new environment and take advantage of the resources that are now available that were not available before. Sometimes those resources can be very limited. So in the case of a volcanic eruption, and even if it happens out in the ocean, which we see these occurring all the time, we have this new island that's going to be formed off of the west coast, I'm sorry, the east coast of the big island of Hawaii. Once that island pops up, it will be inhabited first by plants who are going to take advantage of the new resources, basically the land, and then animals that will come in to feed off those plants, so we get this food web and this food chain going. And these will specialize in taking advantage of an area which maybe other organisms can't survive on at all. You have these volcanic eruptions, there's very limited resources. Some organisms can come in and very quickly take advantage of those. Lichens can break down rock to basically get nutrients out of it, because they are dissolving that rock and getting the nutrients out of that rock. If there is a certain species of lichen that does much better, it will quickly take over, and other species will be at a competitive disadvantage where they cannot compete with one species that's there, and so the one species will take over. But that one species, when it takes over, maybe what will occur is that there will be different aspects of that environment that they will be able to specialize in. So even though one species might come in, the founder species, it will maybe grow on one side of the rock very well until a mutation occurs. And these mutations occur all the time. Compared to my brother or compared to my parents, I have a number of mutations that make me different, even though there's this crossing over of genes that occurs, and the different alleles that I might have compared to my brother or my parents. These will give specific advantages. So maybe the parent lichen that comes in really grows well on the sunny side of the rock, but once that lichen starts to have relations with other lichen, once you have this sexual reproduction going on, those genes being mixed and those mutations occurring, there might be a baby that will have more of an advantage being on the dark side of the rock, where maybe there's a little bit more humidity and there's a little bit less light, and because of that, they will have an advantage of growing there, and because of that advantage, they will thrive better. Their genes will start to occur at a greater rate. This is that frequency of alleles that we were talking about. And so then you slowly have the speciation event occur where one species only grows on the sunny side of the rock, the other species only grows on the dark side of the rock, and this is all due to the addition of new information through mutation. And this is kind of just a slow process, this step-by-step process of adding new information over time because mutations occur every generation. The one thing to point out again is these occur not necessarily in the individual, they have to occur in the population. So you have this slow buildup of these genes over time in the population, and that's what will finally lead to the speciation event occurring. I feel like I'm being way too technical, but I hope it's it's all informative.
I was reading this study recently about these, I think they were mites, that the scientists, they had this population of mites, and they took out all of the adults, all of the mature adults out of the population, and to see what would happen in order for them to survive. And I think it took 13 generations where these mites evolved to mature more quickly, basically. And so that I think, if I understand you correctly, that'd be the event you're talking about to kind of speed this process up a little bit. But most of the time it would take much longer.
Because you're getting rid of something that is competing for resources, correct?
Mm-hmm.
Yeah. Domestication is another way to look at it. I mean, one thing that we have seen as far as domestic species go is there are certain patterns that occur. So all of us know dogs. We have, and some of us have very intimate relationships with dogs. And the one thing that occurs across pretty much all dogs, all domesticated dogs, is this pattern of having floppy ears, of having a certain pattern in their bodies, where you have the light on the chest and the socks on the hands and feet. The tail being something that props up and the ears dropping down. And that's very different from wolves, which dogs have been domesticated from. There was this attempt that is still going on, I believe it's going on for about 50 years now in Russia, where they decided to take a certain breed of fox, I believe it's a silver fox, and they tried to domesticate these fox. And the same thing occurred after a few generations. So these wild fox that have these perked up ears and the tail that is usually straight out back or dropping down, and the single coat pattern, these same things occurred in that species. And even though this is domestication, so of course it's artificial evolution, even though this domestication was occurring, you started to get the same pattern. You started to get the tail that was showing certain emotion and certain behavior. You started to get the ears were flopping over. There's all the behavioral things that were happening as well, but it's this idea of convergent evolution. Even though there is a different species that is evolving, they're evolving in the same direction when certain forces are put up upon them, in this case, humans trying to interact with them.
That's really interesting to me. I'm not sure if you necessarily answered it, and maybe I just didn't pick up on it, but what was it about domestication that caused those evolutionary changes? I mean, did evolution favor those for their survival, or
Exactly.
I'm not sure all of that.
Yeah, so it the ears dropping down means that there's a little bit less of aggression being displayed. The tail being an indication of behavior. So tail up or tail down, meaning something. So basically that the reason that these animals are selected for is usually based off of behavior. You know, we're trying to select the animals, in the case of the fox, in the case of this recent domestication event, we're trying to select the fox that have the least aggression. And for some reason, those indications of aggression are also genes that determine certain behaviors. The ears, the tail, and the coloration. I'm not sure. I'd have to look into it a little bit more myself. I haven't studied the reason why you would start to get this, sox coloration going on and on the breast and on the tummy. The apron is what they usually call it. But it's the great question as to why you have these genes that are linked together. These totally different genes. The genes for actual physical appearance and the genes for behavior. There must be a reason why they're linked.
Yeah, exactly.
You don't have to stay.
Thank you for answering that. Does Aura have a question? I'd love to hear from.
And what do you want to say? It's your turn. Quickly. You can't decide. Did you want to do some of these questions that we have here?
Yeah, I was going to touch on that. So one of the things that I want to ask first, this is from Steve Hayes. He wants to know, what is the most common objection to evolution that you hear? And we touched on if we evolved from monkeys, why they're still monkeys. So is there anything else that is most common, more common?
That's a great question. I think, and this is really getting to real specific communities that you're talking about. So basically, you have certain religious communities that have objections to evolution for certain reasons, and you have other people who have objections because maybe they don't understand the process itself, or there's a little bit of incredulity out there. You explain it to them and they still don't accept it. There's a lot, so I guess we can go into the religious one because it's the most common one. You have creationists out there, and of course you have a lot of different types of creationists. The most common one that we have right now in the U.S. Started back in the 1920s, really didn't take hold until the 1960s, and that's the young Earth creationists. They used to call themselves scientific creationists or creation science. Their objection is that it does not match their scripture. And I think that's a very sad way to try to justify your religion, is by saying that you do not agree with science because it conflicts with your literal interpretation of whatever scripture, and in this case, of course, it's going to be the Bible, that you accept. Because it does disservice to both. It basically says that I need to justify that what is said in scripture is the only reality that is out there. And if there's a field of history or science that conflicts with that, I'm going to say that those things are somehow incorrect. And what they're also doing is they're basically saying that science can't conflict, because science, when it does conflict, is somehow wrong, even though they can't explain why it is wrong. Or to explain why it is wrong, they have to bring up something that is both internally inconsistent with their scripture. Basically there's some kind of conflict there going on, that, I can accept this part, but I can't accept this part. Or they have to be self-refuting. So basically they have to say, okay, I accept this part of science, but then if it refutes this part of my understanding of scripture, I can't accept it. So there's these two different fields of that. And what it really does, I think, is it actually destroys people's faith, which I'm not necessarily going towards. I'm as an atheist, I'm not one of those atheists who wants to make people believe like I do. I'd rather have constructive conversations about why I have my beliefs and why they have their beliefs. I don't want to necessarily attack them on their beliefs. I want to have this conversation back and forth as to why we have these particular things that we do believe. And if they can't back up their part of it, then maybe I can help them understand where I'm coming from, so that they don't feel like I'm just out there to attack them. Instead, I want to help them to understand the way that I have come to where I am at. And of course, this is a little bit hard maybe for me to do in some ways because I was never a believer. Both of my parents are not religious. My mother is a little bit more spiritual, but that is very much based off of her love of nature, being an artist and being a master gardener, someone who works with the earth and works with the materials around her. So I think that the easiest way for us to start to understand each other is to have conversations instead of being in these modes of attack, which just turn people off. They really, some people will just on conversations on Twitter. Once you start to talk about these subjects, once you start to question them as to why they hold these ideas, instead of trying to explain to you, they will just block you and they'll ignore any requests for additional information. I think mainly because they don't have a way to give any information. They just want to say they're right, and they don't want to understand where you're coming from, which is kind of sad.
Or you have something to say?
Well, I have this problem at school where it's all the people in my class believe in God, but I don't, and so I have this problem where they say that God is real. It kind of reminds me that I'm the only one in my class who doesn't believe in God, and kind of makes me sad.
I would venture to say that a lot of your peers are just saying that and not actually understanding it. Mm-hmm. I grew up kind of feeling the same way. One thing that would occur over and over again, I moved a lot. I would move up until the time I was in junior high school and early high school. I moved about every 2 years. And there'd be this thing that would regularly occur is I would move into an area, I would make close friends with the people who were directly around me, the neighbors. And at some point, something would come up, whether it be a holiday like Christmas or Easter, whether it be them talking about going to church. And I would just be truthful, and I would tell them, I don't go to church, and that's not the way I necessarily celebrate Christmas or Easter. And their parents would find out about it, because, of course, my friends would tell their parents. And what would occur at that point is the parents would tell my friends to stop being friends with me. And it would never last long. It would usually last a week at the most. And then I would continue to be friends with these people. And the reason they always gave, every time I moved, it would pretty much be the same line. And the line is that you are a nice person. You are someone who doesn't put me down. You're always friendly. You don't insult me. You don't make fun of me. You're nice, and that was just something I grew up with my family. That's the way that we treated people, and it was not based off of being fearful of God. Which a lot of my friends. And some people who weren't my friends, that's the way they understood that they should behave. They should behave a certain way because they should be afraid. And the only reason that they should be good to other people or that they should behave in a certain way is to be fearful. And I think that breeds a level of hatred of self and of hatred of others who can't actually behave in that way either. Hey, buddy.
Any follow-up?
Hello. Hello, August.
Oh, I think you brought up a good point, and that's the same thing that we're telling her is the students in her class are probably not really thinking about their beliefs. They're just spitting out rhetoric.
Okay. How about you go play Sam and Stella, okay? Go get the iPad and show me Sam and Stella.
No.
I'm sorry.
That's okay. that they're probably just spitting out rhetoric that they hear from their parents, and that she should just continue to be a good person. And the problem that she's describing is actually getting better.
Can you put that down?
Sorry.
Can you put that down? I was sitting. You told me this, but then we moved tables because we moved tables, and so we moved tables, and I actually moved to where the friends that don't hurt my feelings. And I did that on accident, actually.
Mm-hmm. Mm-hmm. Yeah, the main issue, one of the big issues was that she was starting to feel attacked by all the God talk, because I think every atheist has experienced this, where you tell a Christian that you're atheist, all of a sudden they find religion, whether or not they're religious. And I think a couple of these students in her class kind of did that to her, where God was an issue, and then found out she was an atheist or doesn't believe in God because she doesn't label herself as an atheist. Then all of a sudden they had to talk about God, and it just became really important to them. But I think we kind of got off topic a little bit, and that's okay. One of the things that you mentioned that I did want to kind of touch on, which is still just a little bit off topic, was this idea that Christians have, or many people have, is all the answers are in their book. Mm-hmm. And I don't even think that was the intention of the writers of those stories, that all the answers would be there. So it's so fallacious to me that you would even think that all the answers to everything in the world and the universe is in this one book. And it's incredibly frustrating, and it's very difficult, like you were saying, to have conversations, because people, they start shutting down, and then you can't kind of have it. Not everyone, of course. There are many progressive Christians that accept science and kind of reinterpret the Bible to be more metaphorical, but the fundamentalists, they're almost impossible to talk to, because they have this idea that all the answers are in that book, and
mm-hmm.
so foolish.
And I think that's one thing that we need to look at. There is a huge variation among one denomination or species, if you want to call it that, of religion. So when you're looking at Christianity, you have Protestants and you have Catholics and you have Eastern Orthodox, which I really hate that everyone forgets that. That is a huge part of Christianity, and they're very separate from one another in certain doctrines and dogma. I started out as a comparative religion major, so I am, which was part of a cultural anthropology degree. I really was interested in studying religion, and at some point I realized that I was much less interested in social science. That's just kind of what I grew up having to understand to get by as an atheist growing up. I had to get by with understanding where other people were coming from. My parents had pretty much every scripture you can think of on our bookshelves growing up. So when certain people talked to me and talking about their beliefs, I would quote scripture to them from their own religion, and they would kind of be surprised that I understood this. Then you need to go down, to the next level. So if you're talking about a certain type of Christian, let's just stick with Protestantism. If you're talking about, the difference between a Lutheran and a Baptist, you have a very liberal set of each, and you have a very conservative set of each. And of course, overall, that is very different. Yes, you can. If you want to go get it, do you want to go get it? It's in the fridge. You know where it's at.
It's in the fridge.
Yes. Sorry.
You have 30 seconds. Go.
So what occurs is that you have, these various people within the certain denomination who will disagree with one another. they will say, that this part of Scripture is very much all metaphor, but this part is literal. And they can't even agree on that, even if they're in the same denomination, because you can go from one church to another, and the understanding of dogma and doctrine totally changes. And that is something that, as a religion, they need to figure out. As religious people, they need to, I think, try to have that conflict resolved first with them, so that they have this base that they can really come from and say, okay, this is what we believe. Because at this point, I don't think any of them know, which is why I think creationism is very much a new cult within various religions, because it is very different when you jump over between religions and denominations. You have this cult-type following of certain doctrines and dogma within creationism. Some of them believe that the flood actually occurred, and it occurred, so long ago, and some of them don't agree with that. They don't think the flood was actually a literal flood. They think it was just a metaphor for some type of change within humans' understanding of their relationship with God, with their deity.
So what do you want to say?
So I'm just going back to the problem at school.
Okay, but we want to talk about evolution.
It's kind of that.
Okay.
But I just tried to explain to my classmates of how we evolved and how the Earth was created by the Big Bang. That's how I believe that the Earth was created. And then we started out as bacteria, and then... Daddy, can you go get the cookie with me?
Yep.
Uh-huh.
Yeah, go ahead.
I tried to explain to them, and I believe this.
Uh-huh. And then what happened?
And then they just start to argue, kind of.
Oh, so there was an argument about
Not
evolution
exact,
in your class?
not exactly, but I just try.
Okay. So you're trying to educate everyone in your class about the Big Bang and evolution? Does anyone believe you, or are you the only one?
You're
You're the only one?
I thought that hey, you were facing one believe in God, but apparently they do. That's not atheist talk in general.
Okay. But some religious people also believe in evolution.
Yeah.
Sure.
I just had to.
Right. Okay. So do you think we'll have time to get to some more of these questions, Amanda?
Yeah, I do. We can get into them now. We have a couple of questions on the Q&A. One of them, again, is from Steve Lees, but I think it's an important one, and I want to save it until the end. So hold that thought, Steve. We will get to that.
That's not.
I'm not sure if Financia, are you back? Or
Oh, yeah. No, I'm listening. I'm just doing a little bit of work as well.
grabbing a cookie.
Yeah.
So I think a really important question is why everyone should bother to understand the theory. What is the significance of knowing about evolution?
I don't want to watch it. That's right.
Sorry, didn't quite get that. Can you repeat it?
Why should we bother to understand evolution?
Oh, yes.
What is its significance?
Okay. I think the main significance is how it actually impacts, especially in the field of medicine, our overall health. You have, these vaccines, and this also is something that comes up often. You have, vaccines that come out every year. You need to get vaccinated, because if you don't, you can become very sick. And even, not even every year, if your children don't get vaccinated at a certain time in their lives, they don't necessarily have the means for their bodies to naturally fend off certain diseases. And that is the evolution of the immune system. That's just kind of a way to look at, okay, we have this herd immunity that we build up, basically all of us being immune to certain diseases because we have been exposed to those diseases. So our immune system is evolving within an individual, because immunity is one of those things that can kind of evolve within an individual instead of a population. Because you were exposed to something, your immune system changed. It adapts. Genes are turned on, certain genes are turned off, and that can occur really rapidly. Other ways that it can really affect us is that we have certain adaptations our bodies have went through over multiple generations that lead us to be either susceptible or to certain things, or to have these characteristics that really change the way that we interact with the world around us. One of them would be our teeth. Up until recently, within a couple thousand years, in fact, it's almost been recorded in human history, our incisors used to match. Basically, our top incisors would directly contact the tips of our bottom incisors. And it's only been within, and this has changed across different cultures, within about 1,000 years, in some cultures only a couple hundred years, that every single one of us on the planet pretty much has an overbite, so that our lower teeth go underneath our upper teeth. And this is all due to having the use of utensils like forks and spoons and chopsticks and other utensils to eat our food. And also having the ability to cut up our food into smaller pieces before we actually bite into it. When you're biting into a fruit, an apple, when you're biting into meat, it was very important that your top and your bottom teeth would actually match. It would match up so that you could tear off that piece. But as soon as we got rid of that necessity, all of a sudden overbite becomes the norm in populations. Cesarean sections, wisdom teeth. Many people would die off if those things didn't actually. We didn't have the medicine to actually take care of those things.
I want to use Mom's computer.
Oh, okay.
Watch a video of floating there.
So, those, and we can go on and on through the list of different things that allow us to actually survive nowadays, or certain adaptations that we have to make to our behavior, to the world around us, to actually continue to live as an individual or to survive as a population.
All right. Okay. I'll just go on to the next question before we touch on that Q&A again. So does evolution have any real world or modern applications? I think actually you just touched on that. And things that affect all people now. So I know you talked about modern medicine. Is there anything else you can think of?
Sure, domestication. Perfect example. People don't like the idea of GMOs necessarily, but you've got to understand that domestication of both plants and animals have really led to us being able to survive at the numbers in which we exist now. There's no way that we could survive with almost 7 billion people on the planet if we did not domesticate plants and animals to feed us. And we're taking the next step now. We're basically producing GMOs, which, personally, my wife and I don't necessarily consume, or we have some issues with certain GMO species, but there's applications that allow people around the world to have better lives because we are introducing new genes into populations to increase vitamins or to increase the amount of nutrients that are in foods. Actually adding value through evolution, because we understand that the only way that we can, make these species more nutritious or grow larger is by changing their genetics, which has a direct link with evolution, with our understanding of evolutionary processes.
Great. Okay. So we've got about 10 minutes left, and I did want to ask a question from Steve Hayes, because we, all of us, are parents, and he wants to know, how can I, as a parent, help teach my young kids about evolution? Do you have any thoughts on that? I can say from experience, because he's my husband, we have a 6-year-old, a 3-year-old, and a 1-year-old. So do you have any recommendations for getting started on teaching about evolution?
Can you help me type in my password?
Sure. Some of the main things are allowing them to understand that they are an individual, and they are going to be similar to their siblings if they have any, or different. And some of those things allow them to interact with other individuals in different ways that can be advantageous, or that they have to learn. And I think this is one big thing that a lot of people don't understand about evolution and about their interactions with other people and the environment around them is that behavior is also determined by your genetics. So if you don't have the genetic the genetic behavior, and I'm trying to stay away again from technical terms. If you don't have the genes to be a certain way as far as you act, then you need to change yourself, and you need to be the person who you want to be. So I feel like I'm getting off topic, but I want to kind of just address this, that you have to try to understand how you interact with others around you and how they interact with you. And you need to understand the best way to do that to help you be a better person and help other people understand who you are. And that might take changing the way that you behave. So how do we teach our kids to understand evolution? We need to teach them that there's this huge variation out there, that everyone's an individual, that we all have the way that we can contribute to each other as a society, and that is the only way that we can, continue to live in this world where we want to have, large cities where everyone is interacting together, and we want to continue to, have these peaceful societies because people are altruistic. They want to help each other out, and that is very much based off of evolution. The only reason that we can communicate in the way that we are now is because we want to be a community, a society that helps each other understand how we as individuals are feeling. And I think that's kind of one of the most important things, is to have this conversation so that we can continue to progress and continue to grow and understand who we are and as individuals and who we are as humans.
Okay. Aubrey, I don't know if Aura had any questions before we move on.
No, she wants to make some statements, and I'm trying to encourage her to wait to the end.
Oh, okay.
So yeah, if you just a couple more minutes, and you can talk about.
Yeah, I think we are getting close to wrapping it up. I will touch on these questions from the Q&A, just because I want to make sure that we cover them. But so we have a couple of questions that specifically relate to creationists. Dawkin Mills wants to know, Scientia, what your take is on Joe, I think, Chenkowski?
Oh, yeah, Sienkiewicz, yeah.
Yeah, so he has a couple of books written, and it seems like he takes a pretty aggressive stance on Twitter about creationism. What are your thoughts on him?
No, he doesn't take a very strong stance. He's out there to make money.
Okay.
And I can actually say this about almost every creationist I've ever met and talked to, and the larger ones out there. If I wanted to become, I told Kent Hovind this when I used to call up this radio show. If I wanted to become rich and didn't really have any ethics or morals based off of what I was saying, I would become a professional creationist, because they just dupe their followers into giving them money purely by spreading lies and getting their followers to unconditionally accept what they say without actually checking out that what they're saying is based in any reality. And I think that is the quickest way to make that point, is that as far as I've seen, every professional creationist out there is more concerned about making money than actually addressing the topics and the evidence for the topics that they are bringing up that are somehow refuting science. And it's all fields of science, because once you have a creationist out there, especially a younger creationist, they are not just refuting the biology. They're not refuting the science of biology as far as the change in life over time. They're refuting all science. If you've watched any of the Cosmos series, or again, Your Inner Fish by Neil Shubin, these creationists are basically saying things. They're refuting cosmology, basically the development and organization of the universe, of how planets came to be. They're refuting basic geology. I mean, come on, the flood occurring is going against pretty much every field of science. It doesn't matter if it's physics, chemistry, biology, basic archaeology, and social linguistics. It's going against everything. So when a creationist says something, they're basically trying to say that science is wrong in all counts. And I think that just needs to be pointed out over and over and over again, that creationists are basically saying that there's some kind of worldwide conspiracy out there that science is attacking their particular understanding of the doctrines, the scripture that they're following.
What about Ken Ham? He recently had a debate with Bill Nye, and he thought he brought up some really solid points with in regards to creationism. What do you think about that?
And he kept saying the same thing over and over again. Well, I have this book.
Yeah, there's a book for that.
Yes, exactly. And again, he kept proving that his creationism was nothing more than a cult within a certain religious context. He never pointed out any science. He never tried to actually supply any scientific information for his claims. Instead, he just kept saying, I have this book. Well, yeah, you have this book, but it is not answering the question that was presented to you. And so again, he has this book, but he also has this museum, this ark that he's building, and all of these pamphlets and videos and stuff that he wants you to buy. He's a huckster. He's basically trying to make money off of what he is proselytizing as his religion.
I definitely agree with that. Aubrey, does your daughter have any comments?
I believe that's
What do you want to say?
Okay.
So I'm going back to how why we're interested in evolution, and so I didn't really know what to believe. First, I was a Christian, then I was a Buddhist, and then I'm just like, I don't believe in any of the other religions. So I should just make up own religion, and I just actually wanted to find out how humans were actually made, and evolution was really the bestest answer to my question. And so I went to public library. Me and my mom got a book, Evolution, and we only got to a couple pages, and then we had to return it.
Yeah, we've actually read a lot about evolution and watched, documentaries and things like that about it. And she loves those kinds of things, so it was really easy for me to teach it to her because she'll sit through a documentary and just be glued to it the whole time. She has books about the universe, the Big Bang, and evolution that she's read. The one that she's talking about, we never finished reading it, and we just haven't gone back to check it out again. But I think what she's trying to say, and you let me know if I'm wrong, that evolution provided her with the best explanation. Back here. Okay, I got a thumbs up. Yes. Okay.
I think that's what needs to occur, is there needs to be this kind of change in the way that we talk about these things. I don't want to say that we should start to talk about science as our religion, but I think that we should start to address some of these questions by saying that we get great meaning from our understanding that we are related to all organisms. We have this this understanding that I am as much a part of this world around us as the tree, as the bacteria, as another animal. And the reason that that's important is because life is sacred in a certain way, and we need to understand our interconnectedness between all of these organisms. And even going back further, if you want to go back into our place in the cosmos. And I just love that, the Cosmos series is out there again. I grew up watching this, and reading books by Carl Sagan when I was in junior high school is when Cosmos came out, and I started to read some of his books like The Demon Haunted World and his actual book Cosmos, and started really to get interested in science in that way. And something that Neil deGrasse Tyson has said as well in the recent Cosmos series. And one of the things I actually showed my students just recently was his speech on, what is the most kind of a wonderful thing, amazing thing that you can tell us about anything. And Tyson said it very well. And he went back and he mirrored what Carl Sagan said, is that I am part of the cosmos because of the fact that the elements on our planet were cooked in these stellar engines around us. And they cooked lighter elements into heavier elements. And the only reason that we exist now on this planet is because we have these heavier elements that were spewed out by supernova that condensed and formed the planet and the solar system that we now exist in. And so not only am I, part of this world, that makes me part of the universe around us. And it makes me feel interconnected, so that I don't feel like I'm, just a speck in the universe. I feel like I am part of the universe.
Did you have a question? We have to wrap up.
I had a question. So, if there was one, there might have been tons of bacteria, one of bacteria that we evolved to, but there would have been little at first and then made more, which is about reproducing, but, if there was only one bacteria thing, then if there was, I have this question that how could that one bacteria become a host that
How did one bacteria reproduce?
yeah.
Okay.
Yeah, no, that is a great question. I'm sorry, did you want to add something?
No, I want you to answer it.
Yeah. There's the tree of life has roots, and your daughter just brought up the roots of the tree of life. So the concept is that all organisms today came from what is called a LUCA, a last universal common ancestor. But once you get into the realm of bacteria, you actually have many common ancestors. And this is Lynn Margulis bringing up something that is now called endosymbiosis. Basically, what has occurred... Okay, I'll stay here. What has occurred is that we have someone jumping on the bed. We have inside of each one of our cells, we have a little organelle that has its own set of bacteria. It's in the shape of a ring. The interesting thing about that, not only that we have two sets of bacteria in each one of our cells, that ring shape goes back to simple bacteria. Simple bacteria have this ring-shaped DNA. That's how they're. Okay. That's how their bacteria are actually contained. I'm sorry. That's how their DNA is actually contained within those bacteria in the shape of a ring. So what that means is that these mitochondria within our cells used to be a free-living bacteria, and somehow it got integrated into the cell that we have within our bodies. If we look at plants, we actually find that there is a third set of DNA contained within chloroplasts. So chloroplasts and mitochondria in plant cells have their own DNA. And if we trace those DNA back, and we should look at organisms today that have similar DNA as far as the coding, the pattern go, what we find is that basically our bodies, all large organisms like plants and animals and fungi, have come about because we have integrated within ourselves other organisms that do different functions. And again, that kind of connects us to the world around us. So we have this heritage that extends way back beyond us. And at some point, because a single cell, a single bacteria, can't really live well on its own, once it integrated these other bacteria into its cell, it gave us the opportunity as what is called now a eukaryote, is the way we name it, gives these eukaryotes this special way to interact with the world around them, where they can start to grow bodies, where they can start to have multiple cells together that are doing different functions. So it allows us not to be just this one-celled individual, but a body of cells that specialize in different things, because they have the ability to create energy on their own, their mitochondria or their chloroplasts, and to build and contribute to the community of cells around them to make these large communities, which we call our bodies.
I think her question was more pertaining to the cell replication itself, and how a single bacteria could then replicate into two bacteria.
Oh, okay. Sorry, went off on a total tangent there.
How a specialization can be.
Yeah. So I guess mitosis.
Right.
Splitting and recombination. Yeah, just they split apart.
I will find a video on that and post it in the links with this video, because I think that's a really great question. Very misunderstood. And we are running out of time, so I can't. I think we don't have time for the explanation, but I'm sure there's a really great video out there for it. So I will find one and get that link up there.
Yeah, and I know you had some books, Aubrey, that you recommended to me about teaching evolution to kids that we could put in the description, so that the viewers can check it out. So yeah, we have gone, oh, I've got an echo now, yuck. So we have gone over our time, so we should wrap it up. Before we go, I did want to ask either you, Aubrey, Aubrey, do you have anything you want to plug or talk about before we go?
I don't have anything at the moment that I would like to plug, except for our own show. Keep watching.
Of course, yeah, I was gonna talk about that last.
Hold on. Okay. And then, I don't have the information in front of me, as you know, Amanda. But the time and day of the webcast is changing.
It is. Yeah. I can't remember. Is it after next?
20th?
It's after next
Is
Sunday.
it May 20th, the next one?
I'm sorry?
Amanda?
I
think I froze.
Okay. So I think it is the Sunday after next that we are changing, because next week are we having Hina back, Aubrey?
Yes, and it's May 20th, right? I'm afraid to look it up because my internet connection is so bad.
Okay, yeah, I think it was the 20th. We are changing the day and time of the show. Tuesday at 9 o'clock Eastern Time. That just seems to work out better for everybody who's watching and us while we're hosting. So yeah, starting next Tuesday, we'll be every Tuesday at 9 o'clock Eastern Time, which of course is 6 o'clock for me because I'm on the West Coast.
And it's Hina Data Boy.
And she's talking about Islam, right?
Correct.
Okay, great. Okay, Scientia, do you have any projects or any work that you want to promote before we go?
Not at this time. I am trying to set up my own podcast, but it's been going slow. Being a teacher, I think I might try to do the first over the summer and see how it goes from there. But thank you so much for having me on. It was a pleasure.
Yes, thank you so much for coming on. Hopefully we can get you on again because this was really informative.
I need to come up here.
So yeah, thank you so much for watching Godless Family webcast. For more information, you can visit our website at godlessfamily.com or follow us on Twitter at godlessfamily. And that's all we have for you. So have a good day.
Thanks.